Hi, this is Rob. I'm going to be showing you how to do the exercises that go along with the video lesson, the Pythagorean Theorem. Are you ready? Let's get started. For our first problem, we need to find the length of the unknown side x. Here we go. We have this triangle right here, and we have this side labeled as x, so we don't know the length of this side yet, but we know the length of this side, 3, and this side is 5. And right here is the right angle symbol, and so this side, opposite of the right angle symbol, is the hypotenuse. So that's the longest side. So we just need to plug the numbers that we do know into our Pythagorean theorem equation, and then we'll solve for x. All right? So I'll write over the basic plane equation over here. A squared plus b squared equals c squared. And so either one of these can be a or b. We'll choose 3 to be a. And then x will be b, and 5 is c. C is the hypotenuse. All right, so let's plug in the numbers we know here. So we have 3 squared plus x squared equals 5 squared. All right, so first we'll do the exponents, the squaring. So 3 squared is 9. 5 squared is 25. Then we have the plus x squared right here. Equals, so 9 plus x squared equals 25, and we want the x all by itself on one side, so we'll subtract 9 from both sides. So minus 9 on this side just leaves x squared, and minus 9 on this side is 25 minus 9, which is 16. So x squared equals 16. Now we need to take the square root of both sides because we have x being squared over here, and we want x all by itself. Square root. So that leaves x on this side because x squared, the square root of that is x, and x equals, and the square root of 16 is 4 because 4 times 4 equals 16. So the length of side x is 4. For problem 2, we need to find the length of the unknown side x, and we're given this triangle here, which has two sides that are labeled length 2 and length 6. And then this side here, which is the hypotenuse, it's opposite the right angle. This is labeled x, so we don't know the length of the hypotenuse this time. So let's go ahead and plug in the numbers that we do know into the Pythagorean theorem formula. So we have 2 squared plus 6 squared equals x squared. And so we just plug the 2 and the 6 into the a and the b on this side, and we plug the x into the c on this side. It starts out as a squared plus b squared equals c squared. So now we just need to solve for x. So let's do the squaring first. So we have 2 squared, and that equals 4, plus 6 squared, that equals 36, equals x squared. And we'll leave that as x squared for now. So we add these two up. 4 plus 36 equals 40. And then we'll leave this as x squared. Then I'll move over here, rewrite it as x squared equals 40. Then we need to take the square root of both sides. Square root of both sides. So the square root of x squared is x. And the square root of 40, well, that doesn't simplify really easy, so we could just leave it as the square root of 40. Or if you know how to simplify radicals, then you'll know that that would simplify to 2 radical 10. And if you need to get a decimal number, just plug it into a calculator and you'll get something that's like 6.32 something something something. So the length of the unknown side x for this triangle is the square root of 40, or 2 times the square root of 10, or 6.32 something something something. For problem 3, we need to find the length of unknown side x, and we're given this triangle right here, and it has lengths of the square root of 7, and the square root of 5, and then x. So the square root of 7 and the square root of 5 are the lengths of a and b, because remember a and b are the edges that touch the right angle, and then the side opposite of that is the hypotenuse, or c, and that's labeled as x right now. So we need to find the length of the hypotenuse. All right, so let's go ahead and plug these into our equation, and we have the square root of 7 squared plus the square root of 5 squared equals x squared. All right, so we just need to do the squaring of these known values over here. And it's a lot easier than it looks. You know, we have the square root of 7 squared, and that's just going to be 7. Plus, and then the square root of 5, if we square that, we just get 5. And we have that equals x squared. So we'll rewrite it over here with the x on the left. So we have x squared equals 7 plus 5. So we add those together and we get x squared equals 12. Now we need to take the square root of both sides so we can get the value of x. Square root here, square root here. So on this side, the square root of x squared is just x. And the square root of 12, well, we can just leave that as is. We can put it as the square root of 12. Or we can simplify the square root of 12 to be 2 times the square root of 3. Or you can use a calculator and get the decimal representation, which will be 3.46 something, something, something. So the length of the hypotenuse, the length of x, is radical 12 or 2 radical 3 or 3.46. And for problem 4, we need to find the length of the unknown side x. And this time we have x on there twice. We have this side is labeled x and this side is labeled x. And in addition to the fact that each side is labeled with the same letter, we have these little dashes right there on each edge. And that reminds us, it points out that these edges are the same length. And then we have this edge here, which is the hypotenuse. It's opposite the right angle, and it is 3 times the square root of 2. All right, so let's plug this into our equation. And you might be confused at how we do this since it's the same letter, the same variable for both edges, but we just put it in twice. So we have x squared plus x squared equals 3 radical 2. I'll better put that in parentheses, squared. If I didn't, it might look like it was just squaring the radical 2. All right, so on this side, we have x squared plus x squared. That equals 2x squared. And on this side, we have 3 times the square root of 2, all of that squared. And so the way we do that is we square the part outside the radical and then the part that is the radical that's having the square root taken, and we multiply those together. So 3 squared is 9, and radical 2 squared is 2. So on this side, we have 9 times 2. So we have 2x squared equals, and then 9 times 2 is 18. So to get x all by itself, we need to divide both sides by 2. So I'll do that to both sides, and then we'll write the result over here. So 2x squared divided by 2, 2's cancel out, and that leaves us with x squared equals, then 18 divided by 2 equals 9. So we have x squared equals 9, and we need to take the square root of both sides. We take the square root of x squared and the square root of 9. The square root of x squared is x, and the square root of 9 is 3. So in this case, the length of sides A and B, both these sides that are labeled x, is 3. For problem 5, we need to decide, is this a right triangle? We're given this triangle right here, and we're shown that 2 of the edges have a length of 5, and 1 of the edges has a length of 7. And so if this is a right triangle, this would be the hypotenuse. This is the longest side. This would be the hypotenuse. So that would be the value C in our equation. And these would be A and B. So let's put those in. We have 5 squared plus 5 squared equals 7 squared. And this equal sign is just for convenience because we're just checking to see if it fits the equation. This might not equal that. So we're not really sure if this is true. That's actually what we're trying to find out. But don't let the equal sign confuse you if these aren't equal. All right, so 5 squared plus 5 squared equals 7 squared. So let's do the squaring, right? So 5 squared is 25. 25 plus 25 equals, and then 7 squared is 49. So we have 25 plus 25 equals 49. 25 plus 25 is 50. So we have 50 equals 49, and that is not true. That is not true. So this is not a right triangle. We write no. For problem 6, we have, if the longest side of a triangle is 10 meters and the other two sides are 6 and 8 meters long, is it a right triangle? Well, how do we figure that out? Well, we take these numbers and we plug them into the Pythagorean theorem formula, and we see if it ends up being true. So the longest side is 10 meters, so that would be the hypotenuse. And then 6 and 8 would be sides A and B. So let's plug it in. We have 6 squared plus 8 squared equals 10 squared. All right, so 6 squared would be 36 plus 8 squared, which is 64, equals 10 squared, which is 100. So 36 plus 64 equals 100, and we have equals 100. And that's true. So yes, if a triangle has the longest side of 10 meters and the other two sides are 6 and 8 meters long, then yes, it is a right triangle.